Okay, so now we've looked at a lot of different parameters, a lot of different transformations. Now we want to actually start to use that information and combine it to create something a little more visually compelling, a little more robust in terms of showing all the different conditions within this modeling technique. It's always good when you're starting to visualize data to try to find a minimum of at least three unique characteristics to separate the data. Some go-to kind of parameters or conditions to look at are difference in size, difference in potentially shape, color, and maybe even distance. So we're going to look at how three of those start to work together in this script. So in this case, I'm going to create a 3D grid. In this case, I'm actually going to do a randomized grid of points or cloud of points. So I'm going to start off by just creating this 3D box. And again, to keep it as a true cube, I know it's 15 by 15, so I'm going to give it also a 15 value. I'm going to reference that as a B-rep. And go ahead and hide this geometry so I can actually see what's going on. And now I'm going to go to vector and just populate it with a bunch of points. For this, you might want to have somewhere as a minimum of 100 to somewhere in the 200s, 300s, maybe even 500s. I'll stick with 250 for now. And what I want to do again is kind of compare all these points with a series of other points, and we'll start off with 3 or 4, maybe even a couple more. So I'm going to go ahead and start to move these all up at once. Let's actually turn this off a little so we can see a little better. Let's add one more point. Maybe I use this to kind of help within my bounding box. These points don't actually have to fit within that bounding box. It just helps with certain things, but these could actually go outside the box. It shouldn't make a huge difference. So here's my random assortment of points. Let's go ahead and turn this back off. Now I'll reference these points. And again, just like how we've been doing it, I'm going to find the distance between all of these. So closest point, oops, don't disable it, turn that on. So the first thing I'm going to do is actually assign a shape and begin to affect its size. So again, I showed you how you can start to reinterpolate that data as well as the shape. So maybe I wanted to have a little more of a dramatic differentiation between all of this. So I'm actually going to go ahead and from the start begin to remap those values. So again, I'm going to start off by just creating a sphere at all these points. Or actually, before I do that, it's kind of a good way to remember is that if you're moving something, it's always to kind of redo or assign a shape to the points you've moved, and then if they have a shape, then apply that. So there is some kind of logic or understanding that needs to go in terms of the order of these transformations. So it's easy to actually move these points first, treat these as an attractor, and then go from there. So again, I'm going to first find the distance or the direction between these points to these points. I can then start to move them using an amplitude. So I'm again going to use all the same kind of things that we've talked about before, but just adjust them accordingly. and using them in that operation. So again, the amplitude, I can start to create that attractor quality. So I'll go to math, divide its length by somewhere between 0 and 30. I'll make sure that that gets capped at whatever that lowest value is, so utility minimum. And that way, again, as I move them, they start to kind of shrink within that. So we can kind of start to see these clustering of points throughout. And so now I can start to actually, so I've done my first transformation of moving these on a vector. The next thing I want to do is change the shape of the circles. So let's say the closer that new distance is, the larger that sphere is, and then we can color it from there. So now let's assign, again, now we can assign the sphere to these new points and essentially give them all radius depending on their proximity. So this is essentially how much it's moved, but we actually want to use its relative distance. So either that or the length, it doesn't really matter, but we are going to remap those values. So I'm going to go to math, remap, because this is really just kind of determining how much they move. But this, again, kind of what I talked about before with when you begin to remap the values, that they are going to be differing because you're using one type of numeric value versus another. So this creates my bounds. And then again, so if I look at the radius, I mean, that's kind of a decent radius size. We can always alter it, but knowing that maybe that's probably the largest, which is at a 1, kind of gives us a good baseline measurement. So I know the closer I want it to get, maybe we can do something like 0.25 less than 1, less than 3, just to give us some wiggle room. And then for the smallest, because I want them to be smaller the further they are, we can use something like that. Now let's plug this into there. So now we can really start to see that that clustering, they're much larger. Maybe we want to create a more dramatic difference. So if I want, I can make these a little bit bigger. These ones even smaller. So again, it's still kind of a linear interpolation, so maybe you do want to have more dramatic effect where it's important to kind of do some graph mapping. So this is one kind of result. Let's look at what happens if we do kind of use a graph mapper for this. So I'm going to copy and paste this. So this is already starting to show how you can already look at several different iterations pretty easily. So I'm just going to kind of keep this domain because that's going to go to our default graph mapper domain. I'm going to change this graph type to a Bezier. And again, I might want to just multiply these values by a little bit more just to adjust them that way. So again, it will look a little bit different, but let's, so in this case, because we do want to invert it, so the closer, the larger, so we actually want to flip these around. Now you'll start to see how that's working. And so you can see that it is slightly different if I want those to kind of shrink a little bit more so there's a little more contrast in these values. We can see what that looks like. Oops, I guess it would help if I turn that one off. Right, so this is how they start to compare, where those points are much smaller and has a much kind of wide range. So maybe I want to kind of affect them a little bit more. Maybe it's 6 out of round 1. So you can really start to kind of alter what that looks like to create a pretty interesting representation. So the next thing is, again, I don't like the way the spheres look like as B-reps. I like them a little bit more when they're shown as shapes. Let's see if this works, because there's a lot of overlap. Let's see what happens if I go and do something that we haven't really covered over. But if I take B-reps and I actually start to create a solid union, let's see if these start to kind of merge some of this. Let's turn this off. And it does look like it did clean up some of those, which is great. So I don't see any of that kind of same overlap that was before. And if they begin to intersect, they'll actually merge together too. You can kind of start to see how that works. But now I'm going to take these and convert them to a mesh so they look a little better. Turn that one off. You can even see that there's some points in here that I don't want to see. All right, and now I want to assign a color to these. So again, same idea where I can go to parameters, use a color gradient. I can use this remapped value, or I can use the original. Sometimes whenever you start to do this, it's good to use those same values. So I can take these to plug in as my kind of pool of data. I can find those ranges, deconstruct it, and actually I just realized because I merged it, now I'm not going to have the same number of values. So if I look at this, I've got 250 versus 109. So instead of doing it that way, maybe we don't want to join them just yet, or we might need to nix that all together. We could do the color based off of the overall volume actually, so we could try that instead of the distance, because it's more or less going to be the same thing. So let's actually, instead of using that, let's use the volume. So basically the larger the volume, that has that range of color versus the volume of other objects. So let's try this one. There we go. So we can just use the volume of this versus that, and hopefully it's the same amount. So 109, 109, perfect. So we'll use this as our new domain. Those are those values. Let's change the color sequence. Maybe it's something like this. Now I can do custom preview. Turn this one off. Turn that on. Oops. Now we've got a series of different colors and shapes based off those volumes. It's you might want to continue to play this because there is kind of a dramatic change, right? It seems like they're either super large, medium, and then tiny. So you can start to kind of shift some of these pieces over to kind of give yourself a little more range. Right, so now we can start to see a little more variety because there is quite a dramatic difference. So in this case, maybe I actually want to switch these. And then the green is dark, that's fine, but I do want a little more variety towards these smaller shapes. Oh, there we go. All right. And there you go. So now you can start to see how we can use multiple things, and the script doesn't get that crazy. It's pretty reasonable still. But this is how we can start to combine that different data to indicate shape, color, size, proximity. All that can start to create something a little more comprehensive.